Martin, and I am a representative of company Danfoss. I will speak about district cooling and future of district cooling in our cities on behalf of Mr. Jan Erik Thorsen. He had to leave this morning, so he asked me to fill in. As you have already heard and you already know, Danfoss is very active in district heating segment. But nowadays we in Danfoss hear that district cooling has a more focus. We are hearing it about cooling each day, and one of the main reasons for this is that economy is on a growth, and we have much more focus on fulfilling our comfort needs. If we take a look, for example, Europe, cooling in Europe is only covered by 27% in a commercial segment, and in residential segment, cooling is covered. Needs for cooling are covered only by 5%. For example, in comparison to USA, where saturation is 80% for residential and 65% for commercial, or Japan, which is extreme, which has almost 100% coverage of commercial needs and 80% coverage of residential needs. We live in let's say a geographical area which has a huge potential to solve its cooling needs in a very smart and energy efficient way. These pictures are something that we are not seeing only on the internet. We see it in our neighborhoods. Local decentralized systems that are used for cooling, and they're not problem just because they look bad and they're making our facades look ugly. There are other problems also. One of the problems that we see is noise. These are densely populated urban areas, and in these urban areas noise is a big issue. Also heat, which these decentralized systems are generating, is also a common problem. So it's not uncommon that you walk in a street where it's very hot because we have exhaust from localized systems. Municipalities and cities have much interest in developing district cooling systems. These systems are increasing efficiency of existing district heating systems. They can be used to boost energy efficiency in cogeneration systems. Also, there is a big market for cooling energy, so there is a chance for a big profit. And also, environmentally friendly solutions are always welcome, and we are facing climate changes, so we are pushing and striving to achieve less impact on our environment. If we are solving our problems and needs for cooling without district cooling, we are facing several issues. Generally, when we are designing a cooling system for a building, these systems are designed for peak loads, and we usually have some reserve. This means that our systems are generally oversized. And also, if we take a look at this diagram here, which is showing a load profile for different types of buildings, we will see that different types of buildings have different needs for cooling. But also you can see one trend, which is, let's see if I can show it. There is also a clear peak. So during the day and during the night, we have a low need for cooling. District cooling systems can use this, let's say, characteristic of buildings. They can cover these needs with so they can smoothen these peaks. We can use large thermal storages, and we can optimize cooling production, and we can reduce capacity investment. Also, these huge cooling demand peaks are creating electricity demand peaks, and we can also smooth these peaks by accumulating energy in thermal storages. So on this diagram you can see how during the night we can charge these thermal storages, and during the day we can discharge and use stored energy. As we said, on a building level we have unnecessary waste of energy. Systems are oversized, so this means that most of the year they are working with only 20, 30, 50, 60% capacity, and this means that they are not working on optimal energy efficiency levels. Also, there is an issue with the maintenance. Usually the building owners does not have proper maintenance, and also we have an issue that we do not have energy managers present in each building. It is a known fact that fouling in the system can increase energy consumption by 17% based on research made in USA, and it's well known fact that only 0.15 millimeters of biofilm can increase electricity consumption in cooling system for 6%. So this is where district cooling companies come in. They're focused on producing cooling energy. Their business is cooling energy, so it's in their interest to operate at peak efficiency, and the surplus of heat can be transferred now to district heating system, and by doing this we can actually reduce cost for both of systems. One of the risks when we are not using district cooling system is that we are locked for one fuel. Typically in a commercial buildings and in residential buildings we are using centralized chillers which are powered by electricity, or we are using some VRF systems which are also powered by electricity. So we are locked into electricity as our only source of energy. So prices of energy is changing, and this means that we are dependent on the price of electricity. Our colleagues before me were speaking about geothermal energy, about solar energy. All of these energy sources can be used in district cooling. For example, if we have good conditions and favorable conditions, we can use free cooling. If we have, for example, water source somewhere, lake, ocean, maybe river, we can also use free cooling in these cases. And we can use geothermal zones or similar sources. One thing that is noticeable is that once we have a district cooling in the city, it grows rapidly. We see here development of district cooling in Stockholm, in Solna, in, I don't know how to read this, also in Helsinki, and we see also, almost everywhere exponential growth in these cities. But did you notice something interesting in these cities? These cities are all in Scandinavian countries, and who would say that in Scandinavian countries we have a need for district cooling energy? Yes, we have actually, and district cooling is not reserved only for warm climates. We have a type of objects like shopping malls which need cooling all around the year. So also northern countries are attractive market for district cooling, and in Helsinki they produce around 1 terawatt of cooling energy, and this is approximately a third of world's production of cooling energy in district cooling systems. So how do we estimate if we have a potential for district cooling network. Consulting agency Ramboll has developed a simple but effective way to quickly estimate a potential for district cooling. They're drawing on a map, they're putting let's say dots which are representing needs for cooling, and the circles that are drawn around are its size is based on requirements of cooling energy. When we have a densely populated area and the circles are overlapping, it makes sense to investigate and to see if there is economical reason to develop district cooling in this area. As regard, when we are talking about equipment, district cooling requires same equipment as district heating. There is a usually interface in a building, and this is usually a district cooling substation. We in Danfoss have a lot of experience with the district heating substations, and this experience is transferred to district cooling. Principles are same, but there is, let's say, higher need for precise control, since we are working with low delta T's. Heat exchangers need to be very efficient because logarithmic medium temperature difference needs to be very small. It's around one degree, and also everything is bigger. We have, let's say, for same capacity, 2 or 3 pipe sizes higher pipes in district cooling applications. One thing that is a biggest challenge for district cooling is that we need large investments, and usually these investments come in the worst period. So in the beginning we need to invest a lot in very expensive equipment. We need to find a space for it. We need to build a thermal storage. Some of the colleagues explained how those are built. We also need a piping network. This can be challenging in densely populated areas, especially since these are large dimensions. We also need to deal with noise. Noise is something that is now centralized. It's only in one space, and it can be dealt with building sound barriers. We also need to fight low delta T syndrome. This is a syndrome in which our installation in a building works with very low delta T. I have been a witness of several installations with heat pumps which are working with delta T 1.5 or 2 degrees. This is not energy efficient, and we need to take care about energy efficiency when we are talking about district cooling, because if we are not doing this, we will be going to pump large amounts of water, and pumping energy then comes in focus. Also, one thing that is, I wouldn't say issue, but it's a challenge, is that these systems are growing very fast. So we usually install district cooling plant, we plan how it will develop, but then suddenly we have a much more demand than the one that we can supply. But all of these challenges are solvable. It requires good planning, and it requires a high focus on operation. Some of the power drivers that we said, it's economy of a scale. Large scale operation is always much more efficient than an individual system. Also, district cooling systems are environmentally friendly, and actually it's easier to monitor pollution in centralized system than in decentralized system. District cooling systems are fuel independent and have a much higher efficiency. One of the benefits that we are getting is we are saving space because chillers and cooling towers usually take up all of the roof space. Also, we reduce handling of freons. we know that F directive is coming in, and it will be enforced in 2020. So we have now in district cooling systems localized usage of these F gases, and they're, let's say, very environmentally unfriendly. Also, inside the building, substations are virtually silent. Only thing that is making noise is circulating pump, and this is for our systems virtually silent. Also, we have a security in supplying energy. It's rare occasion to see that, for example, district heating system is not working. So these cases are very rare, and the reliability of this system is very high. So we have some conclusions regarding district cooling system. First conclusion is, wherever we saw district cooling system is established, it's very quickly growing. It reduces environmental impact, and also it enables using different, let's say, different sources, and it enables usage of thermal storages, so we can shift load electricity peaks, and we can use the, let's say, economically best source available at the moment. Definitely the district cooling system can be used to deliver heat from the building back to the district heating system, and in this way we are lowering the cost of district heating system. And district cooling also moves these peaks in electricity production. So it is definitely that district cooling is a future of let's say, cooling, at least in Europe, and we should all strive to make it possible. Thank you for your attention.
Thank you very much for, I think this is very important, because we are talking about heating and cooling, and generally there is a lack of awareness of cooling solutions. I think what I like as well is that you highlighted the need of greater information, for example, mapping of cooling demand and densities to help the decision making to make investment in those solutions. As well, you mentioned that there is a need, because, for example, you say the district cooling system can help the district heating. I think we need a systematic approach to look at renewable heat solution and waste energy, because at the end district cooling can help reduce primary energy consumption, and this will help to implement more of those solutions in the urban context. Important part as well, social acceptance. You mentioned it. This is a big factor in urban areas to have projects on the ground. So working on social acceptance as well will make the difference. Thank you very much. Do we have final questions on cooling solution? I see none. So if there is no more question, I'm going to thank you very much for your presentation again. And I'm going to call Greg.